Captain Peter Cutsey speaking. Our briefing today is a no engine bleed takeoff and landing. There may be situations in your flight operations where your company will request certain payloads out of, let's say, a high altitude airport, such as the one we're sitting at today in Kabul, Afghanistan, at 5,877 feet above sea level. There are ways in which we can actually increase the efficiency of our aircraft, that is, more power for a certain situation by doing a no engine bleed takeoff. So there are procedures in the FCOM, in the supplementary procedures, and that's what we're going to cover today. And I'm using Kabul as an example because it is a high altitude airport and terrain is a consideration. I've actually extracted the information, as I do from all of my briefings, directly from Boeing's FCOM 1, 2, QRH, and of course the FCTM, the Pilot's Bible. I've done a PowerPoint, and let's get right into it. The no engine bleed takeoff, a few notes. This is directly from the manual. If anti-ice is required for taxi, and of course it'll be required for takeoff, but if it's required for taxi, configure for a no engine bleed takeoff just prior to takeoff. Reason being is the no engine bleed will restrict you to the inability to use wing anti-ice. Therefore, you would actually, if you needed wing anti-ice and engine anti-ice for the taxi, you would use it normally, and then just before takeoff, you would configure with no engine bleeds. You need engine bleeds for wing anti-ice. You don't need engine bleeds for engine anti-ice. This is just a quick review of the schematic. The bleed valves, when selecting the engine anti-ice on the overhead panel, from the modulating and shutoff valve, either 9th stage or 5th stage, are actually upstream of the engine bleed valve, as you can see here. So regardless of the position of the engine bleed valve, when selecting engine anti-ice on, which you would if you needed icing for taxi, you're going to need it for takeoff, there is no restriction. Engine bleeds can be off, and you'll still get your protection for engine anti-ice, not wing anti-ice. That's the reason why the statement is here. If engine anti-ice is not required for taxi, which is our case today, configure for a no engine bleed takeoff just after engine start. Well, that's our situation now. We're actually just finished our engine start procedure, and we're ready. So we can go ahead with the supplementary procedure. It's a read and do. Right pack switch, auto. Isolation valve switch, closed. Left pack switch, auto. Engine number 1 bleed air switch, off. APU bleed air switch, on. Engine number 2 bleed air switch, off. Trim air switch, on. Wing anti-ice switch, off, as we've just discussed. There's a note here. The wing anti-ice switch must remain off until the engine bleed air switches are repositioned to on, that's after takeoff, and the isolation valve switch is repositioned to auto. You may ask, why are we closing the isolation valve switch? Is because we've got the APU running right now, incidentally. We didn't shut it down in the before taxi procedure, mainly because we wanted to use it. So why shut it down and restart it up again? So the APU is currently running. We actually, in fact, through this procedure, will be pressurizing the air conditioning system. We're using air conditioning and pressurization system through the left pack. That's why the isolation valve switch is closed. All right, So that's a quick review. And if you notice, we've just formed a large C. We started here and down and across. This is a good way to remember the sequencing of how you position switches. So let's actually go into the airplane now, and we will have a look at the panel. That we just talked about. So in the big C that we started about, we talked about right pack, isolation valve, left pack, engine bleed number 1, APU bleed air switch, and engine bleed number 2. So we've actually formed a C. So that's where we were coming at when we had a look at the no engine bleed takeoff. That's why we've done it that way. All right, so let's get ourselves into position, and then we will continue this briefing. All right, so right pack switch, auto. Isolation valve switch, close. Left pack switch, auto. Engine number 1 bleed air switch, off. APU bleed air switch, on. Engine number 2 bleed air switch, off. Trim air switch, on. O-wing anti-ice switch, off. So we've completed the procedure, and now we're ready for taxi. We'll pick this video up at the holding point for runway 29. So here we are at the holding point to runway 29 on Gulf Taxiway, as we're seeing in this map. That's our actual position, and you can see it outside. Now, just before we do the takeoff, we'll go and review the procedure once again, and also review what we're going to do after takeoff, and a few precautions that Boeing have put in the FCTM and in other manuals. This is directly from the FCTM, and there have been several reports of cabin altitude warning alerts caused by improperly configured engine, bleed air, and air conditioning pack switches. This condition is often the result of crews failing to reconfigure switches following no engine bleed takeoff. You've set the aircraft up, you've achieved the aim in getting the airplane safely airborne. So now you have to make sure that the packs are reinstated at the correct time, of course. Additionally, there have been reports of crews delaying the response to the cabin altitude warning alert because it was confused with the takeoff configuration warning horn. In order to address the problem of incorrectly positioned switches that affect pressurization, the normal takeoff procedure directs the crew to set or verify the correct position of the engine bleed air and air conditioning pack switches after flap retraction is complete. It doesn't say, the after takeoff procedure doesn't say engine bleeds on or packs on. It says set. Why? Because you may be doing a type of procedure that we're doing today, an engine bleed off takeoff. That's why the term engine bleeds and air conditioning packs set is part of the takeoff procedure. So remember, this is very important. Your FCTM doesn't have that much information about engine bleed, takeoffs, landing, and go around, but this particular statement is important, and you should heed it. Engine bleed and air conditioning packs have also been included as specific items on the after takeoff normal checklist. That was over the last many years, they've included it. Additionally, when doing a no engine bleed takeoff, we're doing that today, reference to the no engine bleed takeoff supplementary procedure in conjunction with good crew coordination reduces the possibility of crew errors. That's what we're doing. That's why we're doing this briefing, is exactly for that reason. All right, let's go back to the main menu here and actually go to the engine bleed takeoff. As we did, we went through the whole item. We pointed out the actual C, and now let's have a review about what we're going to do after takeoff. All right. Note, if engine failure occurs, do not position engine bleed air switches on until reaching 1,500 feet or until obstacle clearance limit height has been reached. Engine number 2 bleed air switch on. APU bleed air switch off. Note, when cabin altitude rate of climb indicator stabilizes, engine number 1 bleed air switch on. Isolation valve switch auto. If you notice, the direction of the C is reversed. That's a good way to remember it in how you were trained. So we'll end this video here. This will be part 1 of the no engine bleed takeoff. We'll see you in the next briefing where we'll actually get into the airplane and do the takeoff, and then continue on for the next series of briefings regarding engine bleed landing and go around. Thanks for watching.